Let's start the topic precision and accuracy. Precision refers to how close multiple observations of the same quantity are to each other. Precision means it is a degree of closeness. Means it refers to how close multiple observations or measurements of the same quantity. Clearly it refers to how close. Look at this degree of closeness. It means precision is a degree of closeness. Okay, when there are multiple measurements of the same quantity and they are very close to each other. For example, let us take example is suppose that length is measured of some instrument. Suppose it is length of a rod. Length measurements first time it is measured as 1.23 meters. Okay, another time we measured it came 1.2 meters, and one other time we measured it came 1.24 meters, suppose that. Okay, then they are very close to each other, there is very little difference between them. This is called precision. How precise the measurement values are, means how close the measurement values are. It means precision means the degree of closeness of what the measured values. Okay, the measurements. Okay, here now it comes accuracy is a different thing. It is also a degree of closeness, but from the measured value to the actual value. Accuracy refers to how close. This is also degree of closeness to the actual value. It is the degree of closeness between measured value and actual value. It has only one value. For example, let's take a length of the rod is length is simply you can say 1.5 meters. Okay, so here we see this is only single measurement. Sorry, this is a single measurement, and here in precision what we need multiple measurements. Okay, so in precision we see multiple measurements. Now let us take some cases to understand it more clearly. There can be 4 cases. Okay, the cases are, let's take the cases of precision and accuracy. Now the first case is here. Suppose this is the target. You can say suppose this is the target, and the red points are measurement values. Okay, there are 4 measurement values, and the measurement values are what at the target, and target means actually the actual value. The measurement values are these red points. Red cuts are measured values, and this is the actual value. So here in this case we see that the measured values are very close to each other. It means what? The conclusion here is high precision. Why? Because the measured values, the red plus is very near to each other. And for accuracy, what we see what the measured value should be very close to the true value, or the this one. This is the true value, this is the actual value. This is a smaller circle. The measured values are very close here. All the red plus is in this circle. So the measured values are also very close to the actual value. So here we can say high accuracy also. High accuracy. Another time we take, suppose that this is a smaller circle. This is the actual value. Let this be the measured values. What this diagram shows, the measured values. Let me at first write. This plus is simply showing measured value, and the smaller circle is showing what? A smaller circle is what? The actual value. Now it's clear. Here what we see, the measured values are not very close to each other. Okay, the measured values are one is here. They are not very close, they are farther apart. Okay, so here what we will write for precision, here we will write they are not very precise. Here it is very precise because the plus sign, the red plus were very close to each other, so it was high precision. Here the measured values, the red plus, are not very close to each other, so it is low in precision. So it is low precise, it will have low precision. Okay, and how we will check accuracy? For accuracy we will see it refers how close. This is the actual value, and these are the red plus is what? The measured values are close to this. Okay, they are apart from each other, they are much apart from each other, but this is close to this. Okay, they are close to this value, so it can be said high accuracy. although it is moderate, no moderate, it is high accuracy. And let's take another example. Suppose it is, this is the actual value, okay, and the measured values are somewhat at this point. One measured value, another, okay. The measured values we see here, what we will say about precision, they are close to each other, they are not apart like this figure. One is here, another one is here, this is apart from each other, but here all are close to each other, so it is high precision, highly precise. And in this case, this is the target, or this is the actual value, and they are apart from, they are apart from the actual value, they are very far. So this will, what will be here, accuracy. In case of accuracy, it will be low accuracy, because the measured values, this plus sign is far from this actual value, okay. They are not close like this or like this, okay. So it is far, so it is low in accuracy, low accuracy we will say. Another case, we can also take, let it be, this is the actual value, and the measured values are, you can say here it is 1 2 3, suppose this one, okay. Here what is seen here, how we will write about precision. What we see, for precision, we see the measurements, that is the plus sign, red plus, is how much close to each other. Is it close to each other? One plus sign is here, another plus sign is here. They are not close. So it is low precise. We will write low precision. And for accuracy, what we see, this is the actual value, and the one measured value is here, one is here, it is here. Some are near, but some are far also. So it is low in accuracy also. Why? Because the closeness is very less, or you can say the far points are very more. Okay, so it is low in accuracy, low accuracy. Thus here what we concluded, both precision and accuracy, both are closeness, both are degree of closeness, but the references are different. One is closeness of multiple measurements, one is closeness among multiple measurements, and another one is closeness between actual value and one measured value, okay. Accuracy is closeness between measured value and actual value, and precision is what? Precision is closeness among multiple measurements, okay. Both are closeness, but one is closeness among multiple measurements, and another is closeness between measured value and true value, okay. Now there is a question of precision and accuracy. Here it is given, the volume of water is 24 liters. A man measures the volume and finds it to be 24.2 liters, 24.3 liters, 23.9 liters, 24.1 liter in the first, second, third, and fourth trials respectively. Which statement is correct? Now this is the question. The question is that actual volume is 24 liters, and the measured values, four measured values are this four, okay. Now the statements are given. Let me show you the statement. Let's see here, okay. Let me show you the solution. Actually they are neither precise nor accurate. Is it correct? Are they precise? Means the measured values should be close to each other, okay. The measured values are close to, they are in fact close to each other. 24.2 and 24.3 is close to, and 23.9 is also not so much far from these other two values. This is also 24.1 is not so much far from this or this, so it can be precise, okay. The first conclusion is precise, okay. And is it accuracy? Means the measured value and one actual value, okay. But here there are many measured values, so the accuracy will be found by only one value with respect to this one. This is the actual value, one measured value and one actual value. So accuracy is some doubtful thing. Only we will try, the options are not given for finding accuracy actually. In fact, the options are not suitable for accuracy. So clearly this is the right answer. They have poor accuracy. Is it right that they have poor accuracy? In fact, if we will measure accuracy with respect to this measurement, this is good accuracy. because there is very little deviation, only 0.2 liters. This one very little deviation. This is a good accuracy. Okay, with respect to all the measurements, they have good precision. Yes, correct. They have good precision. Precision means the closeness among measured values only. Measured values are this. They are close to each other. They have poor precision. No, this one is wrong. So this one is the right answer. Okay. In fact, the rightmost option should be they have good precision and good accuracy. Okay. Now one other question. The question is, let me show. Okay, the solution. Yes, here it is the solution 24 liter. The actual value and the measured values are very near to each other. So good precision and good accuracy also, because each measurement, each measured value is very close to the actual value. So good precision, good accuracy would be the rightmost option for this question. But the option is only good precision, so it is number 3. Now one other question is, can results be precise and accurate? Is there any result which can be precise, very precise and very accurate? Yes. This result already we saw in the above question that the result the result is very precise and very accurate. Yes, it can be. The solution is yes. Okay. Now let's study uncertainty and error. That topic was precision and accuracy, and now it is uncertainty and error. What is error? We know that it is a difference. Error is the difference between what? Difference between measured value and actual value. Difference between measured value and actual value. Error is difference between measured value and actual value. Suppose the measured value is, for example, we can take the measured value of a pencil is how much it can be 8 centimeters. Okay, and actual value or true value is, suppose that 7.5 centimeters. Measured value is this, actual value is this. Then what will be the error? Will be how much? 8 minus 7.5 centimeter, that is equal to 0.5 centimeters. This will be the answer. About error, it is absolute. Error is absolute. Okay, this is a property. And for uncertainty, we see this is not absolute. Uncertainty is a range. Uncertainty is a range. This is not absolute. This is a range of possible values within which the true value is likely to lie. Okay, this one is estimated range. What is this? Is estimated range of possible values. This is a range of possible values. This is not a single value. This is a range of possible values. Uncertainty is a range of possible values within which the true value, one true value, will also lie within that range. Okay, and here we see this is typically expressed as plus minus value around the measured value. Okay, this is, you can write it typically expressed. How is it expressed? It is expressed as a plus or minus value around the measured value. For example, we can see if it is written the value is, suppose that 10 plus minus 0.2 the centimeters. Okay, for example, it is written this. And then what we will read about this? We will read that the true value, the true value is likely to lie between this range. How we will find the range? 10 minus 0.2, 10 plus 2. That is what's this, 9.8 centimeter to 10.2 centimeter. And that is, this is a range, and within this range the true value will lie. Okay, this is uncertainty and this is error. Now let's understand it more clearly with an example. In this question, it is written that actual value of a rod is 2 meters and measured, and our measurement comes to be 1.99 meters. Find the error. If error is to be found out, it is simply what? The subtraction. The measured value minus actual value. The measured value is 1.99 and it is actual value is difference between these two. So 2 minus 1.99, that is 0.01. This will be the error. Okay, and if uncertainty, this is the uncertainty. What does it mean? It means the range of values between which the actual value will lie. Okay, that will be what? 2 plus minus 0.02 meters. This will be the range, and is that it means what? It signifies that 1.98 2.02 meters. This is the range where the actual value lies. Okay, if uncertainty is given. Okay, this is the difference between uncertainty and error. Now let's study types of error in the next video.